Hi, boys and girls, it's Miss Bissell. We are starting in our Volume 1 book today. We're going to begin on page 10 with Lesson 1, 2. Topic 1, Lesson 2. So if you need to grab your pencil and your book, I will wait for you. I very carefully reminded everybody during math class on Tuesday and at the end of the day to please make sure you pack your Volume 1 math book. All right, so we are looking at how are place value positions related. So we're back to your place value chart that you boys and girls were introduced to very early on. And I'm going to actually have you flip back to page 9 and let's take a look at our place value chart. So we're looking at our whole number place values, and as you can tell, we have 3 periods. We have our ones period that is made up of our ones, our tens, and our hundreds. We move over to the thousands period where we have our 1,000, 10,000, 100,000. Then we move over to the millions period, and you'll start to see a pattern here. We have our 1 million, 10 million, 100 millions. And if I told you that the next period was the billions period, you could probably predict based on this pattern that we would then have 1 billion, 10 billions, and 100 billions. So one thing I want to mention is where we have a division between one place value period and another, this is where we see the commas in our numbers. And we talk about that a lot when we place the commas in our numbers in class. So just remember the 3 place value positions before the comma is because we are leaving room for the ones, tens, and hundreds place. And then we would have 3 place value positions after this comma where we'd have our 1,000s, 10,000s, and 100,000s. And we've talked about that a little bit in class, so that shouldn't be anything new for you. All right, so let's look at the solve and share. So we have a population of a city that is 1,880,000, and we want to look at the value of the 2 8s in this number. So we're looking at these 2 8s, and we want to know what's the value and how are they related. So this is a good way kind of to introduce the concept. So when I look at these numbers, I'm going to go ahead and plug in 1 in the millions, 800,000, 80,000, 0 in the 1,000s, 0 hundreds, 0 tens, and 0 ones. So, oops, I'm so sorry. I just plugged in my number. Give you a second to plug that in to your actual chart on page 9. Now, I want to talk about these 2 numbers. So I have 8 10,000s here, and I have 800,000s here. The neatest thing about our place value chart is that it is based on powers of 10. So every time you move to the left 1 position, your number is getting 10 times larger. That's why when we are subtracting and we regroup, we are bringing over 1 as a 10. So let me explain that. So if you have 100 and you're subtracting 93, all right, when we subtract, we are going to make this a 0 hundreds, and we make this 100 that we're renaming, we make it 10 tens, right? And then when we regroup out of the 10 tens, we take that 110 and we rename it or regroup it as 10 ones. So every time we move to the left, the digits in the place value charts or the place value slots have a value of 10 times greater than the one on the right. So as I move here, tens are 10 times more than the ones, the hundreds are 10 times more than the tens. So with that being said, let's draw an arrow here and let's see what happens. So if I know that the place value slot to the left is 10 times larger, then I know that 800,000 is going to be 10 times more than 80,000. Okay? So when I look at this, I see that my first digit is 800,000. And my second digit I'm sorry, this one is 800,000, the one on the left. The second digit is 80,000. So when I compare those numbers, looking at the chart, I can see that 800,000 is 10 times as great as 80,000. So that's how those numbers compare. Now, one thing I notice is when I write these numbers, 800,000 versus 80,000, when I write them out, when I'm just looking at their individual values, I notice that 800,000 has 5 zeros, 80,000 has 4 zeros. So that 1 0 difference tells me that one of them is 10 times greater than the other. All right. Question on the look back. Is the relationship between the value of the 2 8s in 1,088,000 the same as the relationship between the value of the 2 8s in the problem above? So the number's just a little bit different. Instead of having 1,880,000, we have 1,088,000. And actually, the relationship value is going to be the same, because when we look at 1,088,000, I see that these 2 8s are next door to each other. So I see that this 80,000, when compared to the 8,000, is one digit to the left. So it's going to be, or one place value to the left. So it's going to be 10 times greater. And when I look at the numbers written in standard form, I see that this 8, which has a value of 80,000, has one more zero than the 8,000. So it's 10 times greater, okay? So the answer is yes, the relationship value is the same. So the value of the 8 in the 10,000s place is still 10 times the value of the 8 in the thousands place. All right, so write that, pause the video, look this over, and see if this makes sense to you. All right, see what's going on, see if it makes sense to you. All right, let's flip over to the next page. And let's look at the visual learning. This is where the lesson instruction takes place. So we're looking at how place values are related. So according to the 2010 U.S. Census, the population of Phoenix, Arizona is about 1,440,000. What is the relationship between the value of the two 4s? Now, our directions tell us, or our little 5th grade helper tells us, that writing the number in expanded form can help. Now, expanded form is, I think of kind of like an accordion where you pull it out and you are multiplying the digit times the place value for each digit in the number. So if I look at the expanded form of 1,440,000, the value of the 4 in the hundreds place is 400,000. The value of the 4 in the 10,000ths place is 40,000. And we kind of wrote that out without expanded form on the previous page, didn't we? I'm going to see if I can focus that a little better. So here's the standard form. All right, here is the expanded form. So we are multiplying, the 1 is in the millions place, so 1 times a million. We add that digit to the 4, which is in the 100,000ths place, so 4 times 100,000, and we add it to the 4, which is the digit in the 10,000ths place. All right, we're not going to be using exponents, so you can cross this out. This is for 6th grade. Now, Number name, of course, we read it 1,440,000, and we put a comma even in the word form or the number name every time we finish with the millions period, the thousands period. A comma would go in. All right, so sometimes we call this word form instead of number name, and sometimes I've seen it written form. All right, so let's go back. So what they're telling us is if we look at this, we can tell that we have 400,000 and 410,000. And there are 5 zeros in the 100,000 and there are 4 zeros in 10,000. So 100,000 is 10 times the value of the 10,000s. So what that means is if we have a 4 in the 10,000s place and we have a 4 in the 100,000s place, then the 400,000 is going to be 10 times the value of the 40,000, which would be the 410,000s. Okay? So 400,000 compared to 40,000. We can even look at it here written in standard form, just focusing on those two place value positions. There's one more zero in the 400,000, so it's 10 times greater. Now, you could read it backwards and you could say that 40,000 is 1/10 the value of 400,000. So we could move the arrow this way and say that 40,000 has 1/10 the value of 400,000. All right, it's smaller. It takes 10 of those to make one of the 400,000. All right, so we are looking at place value positions, but then all of a sudden they want to take you back to review standard, expanded, and number name. So don't forget, standard form is just how you write a number how you write a number with the digits 0 to 9. Expanded form is where you take the place value digit and multiply it times the place value and add it to the next one. And number name is how you write it in words. All right, so let's just do a couple problems. I think that's probably the easiest way. So if we look at number 1 on page 11, and again, guys, I'm going to remind you that when I'm going through the book, you're pausing and you're working out the problems in your book too. So when you come to school, the problems that I've worked out are also the problems that you've worked out. Now, before we do number 1, I just happened to see another example. So this is really good. Put a star here. It explains that when two digits next to each other in a number are the same, the digit on the left has 10 times the value of the digit to its right. So when I look at these numbers, this is obviously 500,000 and this is 50,000. So 500,000 is 10 times larger than 50,000. This is 5,000. And compared to 50,000, then what I know is 50,000 is 10 times larger than 5,000. But that is when the digits are the same number and you're comparing the digit to the digit to the left. All right, the digit to the left, when you're comparing it to the digit to the right. Now, when two digits next to each other are the same, the digit on the right-hand side is smaller. It has 1/10 the value of the digit to its left. So 5,000 has 1/10 the value of 50,000, and this 50,000 has 1/10 the value of 500,000. All right. Now, put a big star there. Don't forget, that's probably the most important part of understanding how place value positions are related. That's where it's all summed up. All right. That's where the learning is. Now, in 9,290, is the value of the first 9 10 times as great as the value of the second 9? So looking at these two 9s, 9,000 is this one's value, and this is 90. They're not next door neighbors. They're not right beside each other. So no, they do not have that relationship where the one on the left is 10 times larger. Remember, they have to be beside each other, next door neighbors. So no, let's make a note that since the nines are not next to each other, the value of the first 9 is not 10 times the value of the second 9. All right? They would have to be right beside each other for 9 million to be 10 times, or 9,000 to be 10 times greater than 90. Okay? Now, if we had 9,920 as our number, then the 9,000 would be 10 times larger than 900. Or we could say 900 has 1/10 the value of 9,000. But they have to be next door neighbors right beside each other in order to make that relationship, okay? As a matter of fact, let's just talk about this. To go from 90 over to 9,000, we go over 1, 2 place value positions. So it's really 100 times larger. 9,000 is 100 times the value of 90. All right, we're going to write this number in expanded form. So we're talking about writing the digit. If there's a 0 as the digit, we can gloss over it. We don't have to write anything. So writing 4050 in expanded form is as simple as taking the digit 4, noticing that it is in the thousandths place. So to get the value, we would multiply 4 times 1,000. We're going to add it to the 5, and the 5 is in the tens place, so we're going to multiply it by 10. Now, I have seen it written with or without parentheses. I think it's easier to read if you have the parentheses. And then you can see 4 times 1,000 would give you a 4, and 5 times 10 would give you a 5 for 50. Okay? But with or without parentheses, it's acceptable. All right, we're going to now write the values of the given digits. So take a look, they're next door neighbors, the 2 sevens. So we're able to talk about the first digit has a value of 7,000. The first 7, sorry. The second 7 has a value of 700. It's in the hundreds place. And what I know about this, because they're next door neighbors, is that 7,000 is 10 times greater than 700, or I could say 700 has 1/10 the value of 7,000. Moving on to the 2's in 522. These next door neighbors, the one on the left has a value of 20, and the one on the right is in the ones place. It has a value of 2. So what I know is 20 is 10 times greater than 2, or I could say 2 has 1/10 the value of 20. All right, let's write these numbers in standard form. Standard form is just where you have your digits and commas as needed. So one thing that I like to do to make sure that I don't skip spaces, and I highly suggest this strategy to you, is look at the first number. This one has the greatest value, 8 million. And look how many place value slots there are. 1, 2, 3, 4, 5, 6, 7. What I like to do, if that is the largest digit that we're going to be recording, then what I know, is that my answer is going to have that many digits in it. So I like to make blanks. So what I'm going to do is I'm going to put a blank for the millions, 3 little blanks here to fill in the thousands period, and 3 little blanks here to fill in the ones period. Now, look how this is going to make this so much easier for me. 8 million. 8 is going to go in the millions place. This is 300, so I need to find the hundreds place and put a 3. 9 ones, I need to find the ones place and put a 9. So these are my ones, tens, hundreds. These are my thousands, 10,000s, 100,000s, and this is millions. So double checking those digits are in the right place. Now, I put zeros where everything else is. So I have 8, 000, 309, and using that strategy, I can never get this wrong unless I just make a very bad mistake. We're not going to do number 6 because it has exponents in it, but we're going to move over to number 7, and we're going to use that same strategy as number 6. 10,000 is the largest digit in this number. So when I go to put this into standard form, I'm going to put 5 place value slots to write on, 5 lines, and I'm going to put my comma after the first 2. Now, I have 10,000, so I need a 1 in the 10,000ths place. That's going to be here. 20, so I need a 2 in the tens place. 3, I need a 3 in the ones place, and I fill in the zeros, and this number is 10,023, and I have the right number of digits. All right, so use that strategy of putting the number of blanks to match your first number when you're going to standard form from a simplified expanded form. All right, now we're going to write these numbers in expanded form, except we're not going to do it as basic as right here. We're going to do it like we did with number 2. So I start with the largest place value, and I have a 5 in the thousandths place. So that's going to be 5 times 1,000. All right, to it, I add the next digit, which is a 3, and that 3 is in the hundreds place, so I'm going to do 3 times 100, plus I have a 6 in the tens place, so 6 times 10. So when I multiply them together, that would give me a 5,000, a 300, and a 60. And then when I put them together, I get 5,360. All right, let's do the same thing with expanded form here. So again, I have a 1 this time in the 100,000ths place. So I'm going to do 1 times 100,000. The next digit I have is a 2, and it is in the thousandths place. So I'm going to multiply 2 times 1,000. And I have a 2 in the hundreds place, so 2 times 100. So what you notice is when I go from this standard form to expanded form, I'm multiplying the digit times its place value, and then I'm adding it to the next digit times its place value. All right, this one I have 85,011,011. So same thing. This 8 is in the, that's the 10 millions place. So 8 times 10 million, and I'm going to add it to the 5 in the millions place. I'm going to add it to the 1, which is in the tens place, and I'm going to add it to the 1 that's in the ones place. So 1 times 1 that's the ones place, and that's the actual 1. All right, we're almost to the end. We're going to now write the values of the given digits. So we're looking at the sevens. So the first digit is in the hundreds place. So don't we just multiply 7 times 100 to get that value of 700? The second digit of 7 is in the tens place. So 7 times 10 would give me a value of 70. So 700 is 10 times the value of 70, or we could say 70 has 1/10 the value of 700. All right, let's talk about these nines in 990,250. The first 9 is in the 100,000ths place, so its value, 9 times 100,000, would be 900,000. The second 9 is in the 10,000ths place, so 9 times 10,000 would be 90,000. And when I look at these, I could talk about their relationship as far as value, and I could say 900,000 is 10 times greater than 90,000, or I could say 90,000 has 1/10 the value of 900,000. And last but not least, let's look at the ones in 2,011,168. So the first, there's 3 ones. The first one on the left is in the 10,000ths place. So 1 times 10,000, that one has a value of 10,000. The second one in the middle is in the thousandths place, so its value is 1,000. And the last one is in the hundredths place, so it has a value of 100. and I could say that 10,000 is 10 more than 1,000. Or I could say 10,000 is 100 times more than 100, because when I go there, I'm going to place values. So this would be times 10, and that would be times 10. So I'm going 100 times the value. All right, boys and girls, I'm going to go back and look at your question. How are place value positions related? And it's all summed up right here at the top of page 11. When two digits next to each other in a number are the same, the digit to the left is 10 times the value of the digits to its right. And when there are two numbers together, right side by side, and they're the same digit, we could also talk about the digit to the right as having 1/10 the value as the digit to its left. So you have a practice buddy. So do your best on that, and I will see you tomorrow. Have a great day.